Did we do this one? I guess so. There was this one.
This one, it was the end of the other lecture. Nucleotide, coenzyme. Coenzyme are the organic molecules assist enzyme in catalyzing reaction. They help. Assist means help. Often vitamin derived. Bond to the active site of the enzyme, usually functional group transfer as a carrier or in redox reaction, and different coenzyme for different reaction. This fucking information is 80% important, okay? What is the job? What's the role or job of coenzyme? Here wants to tell you, for example, niacin, the coenzyme is NAD and NADP. The reaction catalyzed by niacin is oxidation. If we have a niacin deficiency, we get the pellagra. Pellagra is an allergy of the skin. Skin disease. If the coenzyme is NADH, NADPH, the job is reduction. Riboflavin, that's the other name of vitamin B2. The coenzyme is the flavin adenine dinucleotide and flavin mononucleotide, FMN and FAD, and the job is oxidation. If we have a deficiency of vitamin B2 or riboflavin, we get the skin inflammation. Thiamine or vitamin B1, the thiamine pyrophosphate or TPP is a cofactor. The job is 2 carbon transfer, and 2 carbon actually forms on the acetyl group, and that's very important for the enzyme. The name is pyruvate dehydrogenase complex, PDC. And if we have a deficiency of vitamin B1, we get the beriberi. Lipoic acid or lipo8, the coenzyme is lipo8, the job is oxidation. If we have a deficiency, there is a problem in PDC again, pyruvate dehydrogenase complex. You learn it later.
But is it important? Do we have to know this?
Actually, you learn this table on 4 PDFs, and this is a very good summarizing of all of them. This one is written here.
This one, yeah?
Yes, pantothenic acid. Did you use the shampoo Pantene?
Yeah.
They have a pantothenic acid. It caused all of the whitish hair will be gray. Why? Because the cofactor is coenzyme, is a coenzyme with thiol group. The job is acyl transfer, and it's whitish the gray hair. Whitish the gray.
It's
gray the whitish hair. Okay.
So you will have, when you have gray hair, you will have darker hair.
Darker hair, yes. Pantothenic acid. Now, biotin or vitamin H. Biotin is vitamin H. The coenzyme or cofactor is biotin. The job is carboxylation. Pyridoxine or vitamin B6. The coenzyme is a pyridoxal phosphate or PLP. The job is decarboxylation. If we don't have vitamin B6, we get the anemia. Sometimes the job is transamination or racemization. You know racemization, racemic mixture?
Oh, yeah.
They make a racemic mixture. Sometimes the job is carbon alpha to carbon beta bond cleavage. Sometimes the alpha and beta elimination or beta substitution. It means vitamin B6 has a lot of job. I want to add you something else. The role of vitamin B6 is antiemetic. What does it mean, antiemetic? No, not the deficiency. The role of itself. If you eat vitamin B6, it's antiemetic.
Okay.
And the pregnant women, they can eat vitamin B6. Vitamin B12, and the other name is cyanocobalamin. Cyanocobalamin. The coenzyme is vitamin B12. The reaction catalyzes isomerization. If we don't have vitamin B12, we get pernicious anemia. What does it mean, pernicious anemia? We have a major anemia, minor anemia, pernicious anemia, microcyclic anemia, and microcyclic anemia. Pernicious means we have a lot of red blood cells, but they are not maturated. They are so small size. Okay, in this case, what is the microcyclic red blood cell? Microcyclic is much more smaller than pernicious. It means micro, pernicious, major. The normal is between pernicious and major. You learn it pathophysiology. Folic acid is a folate. The coenzyme is tetrahydrofolate. The job is one carbon transfer. Could you please tell me one carbon transfer example? Methyl, formate, formic acid, formyl, ketone, just carbonyl. Everything has a one carbon, and I need transfer from this compound to this carbon one carbon. I should use the folate.
As well?
Carboxyl also. Carboxylic acid or formic acid. The other name of carboxylic acid is formic acid. Now, if I don't have a tetrahydrofolate, I get the megaloblastic anemia. Megaloblastic or major. Okay, megalo means I have a big red blood cell. Ascorbic acid, the other name is vitamin C. If we don't have vitamin C, we get the scurvy. Why? Because of the 5-hydroxy,
between
5-hydroxyperoline.
This is what we had in the previous lecture.
Yes, it decreased the 5-hydroxyperoline on the collagen. Water insoluble. Not all of them was water soluble vitamin. Now, water insoluble vitamin A. If we don't have vitamin A, what's happened? Vitamin A deficiency.
I don't know.
There is a problem in vision because vitamin A increases the vision. Why? Because of the retinoic acid.
Okay.
Retinoic acid. The other problem, they get the dry skin. Because of that, we have a vitamin A, vitamin AD ointment.
Which vitamin is produced when you're in the sun?
D.
D.
But we have vitamin A and vitamin D as an ointment. That use it for the dry skin. Vitamin D, if we don't have vitamin D deficiency, we get ricket on the childhood and we get osteomalacia in adults. Do you remember last night we studied that?
Okay.
And
I don't remember right now.
osteomalacia. The parentheses, ricket is parentheses, okay?
Yeah.
And osteomalacia in adults. Vitamin E, it doesn't written. What's happened for the deficiency of vitamin E?
Wait.
If somebody has a vitamin E deficiency, especially in the women, they get the irregular menstruation. Irregular menstruation. They are always tired, everybody, because of the vitamin E deficiency. They cannot think properly. They think, oh, I'm angry. Oh, I don't like to feel. Oh, this is a vitamin E deficiency, okay?
So probably I should take that.
Yes, vitamin E is very good, okay? If you want to eat it without medical provision, supervision, just eat it 2 weekly. Vitamin K. Vitamin KH2, it means 2 hydrogen add to this one, is a coenzyme, and reaction catalyzes carboxylation. Could you please tell me vitamin K deficiency, what's happened? What is this symptom of vitamin K deficiency?
Bad vision? No?
K, vitamin K.
Vitamin E. Oh, E.
E. Yeah, like it.
Do you remember? I don't remember.
Vitamin K is used in coagulation pathway. Vitamin K deficiency cause bleeding.
Oh, yeah.
Cause bleeding. This table is so fucking, but that's a very good summarizing.
Okay. So,
No.
100%?
No, you see, this is a good summarizing.
So
Everything is in somewhere else. It's a good summarizing, and you can get it, and this is 200%. Now, what is the nucleotide? Base, sugar, and phosphate. Base, sugar, and phosphate. Now, dinucleotide, 2 nucleotides connect through the phosphate bond. Now, could you please tell me what is the name of these bonds?
Phosphodiester bond.
Yeah, phosphodiester bond. What is the name of these bonds?
Glycogen bond.
Glycosid.
Glycosidic
bond. What is the name of oh, you have one more. Oh. And here is a H bond, yes?
Where?
Between another base. Base and base.
Okay.
That's good. No. Coming here. The coenzyme most commonly used by enzyme to catalyze redox reaction. NAD plus produced NADH, and NADP produced NADPH, FAD, FADH2, and FMN, FMNH2.
Could you like write the shortened way?
Shorten name?
No way of this is like NADH plus 2 ions.
No. Just that's the basic structure. It's fucking okay. No, come on. No, don't. No, the component of NAD: nicotine, amide, adenine, dinucleotide. Okay, where is the nicotine? Nicotine, you have one NAD, very big one. It's here, and this is to distinguish.
So this is not important. Not just to know the structures.
To distinguish, and this is 300% important. 3 times on the last final exam, it's coming to the exam. Now,
300.
what they ask, I want to write the last question. They ask, what do you see? These are the exact question. What do you see? You should write, this is a NAD, this is NADH. No, I want to tell you, what is the difference? How should you understand which of them is NAD, which of them is NADH? See, the NAD, the X is H. Where is the X? Could you please find it? This one. The X is H, this is NAD. Good? The X is H, this is NADH. If it will be phosphate, it will be NADP. Nicotine, amide, adenine, dinucleotide, phosphate. The X is P. Do you get it? No.
Okay.
Here, the difference is here.
And the charge.
Yeah. Reducing agent, oxidizing agent. NADH has a H, one more H than this. Do you get it? Now, we want to learn the different parts. On the exam, all of these parts are in the box. Okay? Now, what's this nicotine amide? Why this is nicotine amide? We should learn it. What is the name of this ring? Pyridine.
Pyridine, yeah.
Pyridine. And this is the amide bond, isn't it?
No, this is not an amide.
This is amide bond, COON. COON is amide, and is a nicotine amide.
Okay.
Now, the niacin or nicotinic acid or vitamin B3 is just pyridine with carboxyl. It means nicotine amide is a precursor of that, or this is a precursor of this one. Adenine is a purine, and purine is pyrimidine and
Pyrrole.
and imidazole.
Imidazole, yeah.
This is a purine, and purine is pyrimidine
Plus imidazole.
plus imidazole.
Plus ammonia.
And does the ammonia, the purine is this, and the adenine, okay, it has ammonia. Do you remember the numbering?
Yeah, wait. 1, 2, 3, 4, 5, 6, 7? Or is
No,
this
no,
like
7 will be
okay,
here.
7.
I'll come back here. No, here. This is what? Nicotine amide. Yes? And see, just emphasize that this heterocycle is pyridine. What is the name of this sugar? Ribose.
Ribose, yeah.
And we have one phosphodiester bond. Phosphodiester bond. Good? Then, what do you see here? Adenine. And what's that?
The ribose.
No, this is a deoxyribose. Why? Because this is OX.
Ah.
It's lose the hydrogen anyway. But if this is in NAD, is ribose. If this is NADP, this is a deoxyribose. Do you get it? Because in the ribose is H and OH. Okay, that's okay. And in the NADP is deoxyribose because it is a OPO3. Actually, it lose the OH and add one phosphate group instead of that. No.
It's the same there, isn't it?
It's same. Everything is same.
So even when there's just one, if there are 2 hydrogen, it's still nicotinamide, yeah?
Yeah. Now, one more confusing thing that it's written here, reducing agent, oxidizing agent. Reducing agent is NADH. Oxidizing is NAD+. Could you please tell me what does it mean? NADH has a hydrogen. NADH lose proton and give proton to somebody else, to something else. In this case, the acceptor molecule will be
The substrate.
or acceptor molecule will be
Oxidized.
reduced. NADH give OH, it means NADH oxidize by self.
Yeah, look, the substrate will be oxidized, not reduced.
No, see, I'm here, not here. I'm here from this side. Go from this side. NADH reduce the substrate and oxidize by self. It means if I wanna come from here, NADH cause the reduction of the substrate, from here oxidation of substrate.
Reduction of substrate, oxidation of substrate.
That's very confusing.
Yeah.
Just imagine again. I have a NAD plus. It has a hydrogen? No. NAD should convert to NADH
Yeah.
by
we see-
accepting proton.
We see that here.
No, forget this one. Just come here to easy one, then you learn the other one. Fuck that. NAD accept the proton. If somebody accept proton, this molecule is
Oxidized.
reduced. Accepting of the proton is reduction. If the NAD reduce itself, it means NAD can oxidize somebody else. It means NAD without hydrogen can oxidize somebody else. Means NAD is oxidizing agent. Again, NADH has proton. If I have a proton, if I donate the proton, it means I oxidize myself. I give it to you because I want to reduce you. It means I am reducing agent because I can reduce you. Understand? Because of just this proton. Do you understand it?
So if it goes in this direction, it would oxidize someone.
No, you see, now come back here. NADH wants to back to NAD. Lose the proton, yes? It means oxidize itself and reduce somebody else. It means NADH is a reducing agent.
Okay.
No. Fuck this one, that's not this. No, what's this? This is a very important reaction, not here on the citric acid cycle, later. And you know, I don't see any citric acid cycle and urea cycle on your lecture. It means you don't print them out.
Yeah, they're not up though.
The glycolysis, urea cycle, and citric acid cycle. This three cycle is in your exam this semester. No. What's the name of that? Malate and oxaloacetate. Again, malate, oxaloacetate. What is the structure? It has 2 carboxyl. You know malate from last semester also, yeah? 2 carbon, 1 OH. Could you please help me to memorize a little bit then? What is the name of 2 carboxyl group? Oxalic acid.
Yeah.
What is the name of 2 carboxyl, 1 carbon between?
No, not oleic acid.
Malonic acid.
Malonic, yeah.
Malonic acid. What is the name of 2 carboxyl, 2 carbon between?
That is...
Do you remember?
Yeah, but I don't remember.
Do you remember 2 carboxyl, 2 carbon?
That's succinic acid.
Succinic acid. Good? It's a very good key. Carboxyl 2 carbon and I have a double bond. Now it was a danger of cis or trans. Do you remember that these 2 names?
No, I don't remember this one. We didn't have that this semester.
If they are, oh, you have it. If they are on the cis position, the name was maleic acid, and it was fumaric acid.
Yeah.
Now, what's happened if I have 2 carboxyl, 2 carbon, and one of them has OH?
That's
This is what? Malic acid. Malic acid, and the root of that is malate ion. Okay? Malate ion.
so the ion would be just double bond. Oh.
Yeah, two COO minus.
Okay.
Now, another important thing, if I have a 2 carboxyl, 2 carbon, and both of them has a OH, the name will be? I see you in danger.
Oh, is it the
The danger of the dying because of the chemistry, okay?
Yeah, sure.
The name is tartaric acid.
Yeah, I remember that.
Now, we have one phrase in Iran that if somebody solved the problem, that's an easy problem. It was so easy. But please read it every day. If you memorize it just one day, if you draw it all of them on the paper, it's easy. Now, comes here. It's a malate. Malate plus NAD. NAD needs proton. From where? From this hydrogen, for example. And this hydrogen, see? These 2 hydrogen. This hydrogen is go away, comes here. We can make them orange. Let's say this edge comes here. Okay?
Yeah.
Always, when you write NAD or NADP, the afterwards should be NADHH plus, NADPHH plus.
Okay.
Because we don't get just 1 proton, always we should get 2 proton. And after that, the carbonyl group will be produced. Now, the name of this compound is oxaloacetate. Why? This part was oxalic acid, 2 carboxyl, and this part is acetate from acetic acid.
Okay.
You remember that one?
Yeah.
And oxaloacetate is ketone body.
Yeah.
Could you please give me the name of all of the ketone body? Oxaloacetate, beta hydroxyacetate, beta hydroxy butyric acid, and acetone. We have 3 ketone body. Why the ketone body are important? Because in the diabetic, the ketone body is a lot and they get the ketosis. And if it is so much high, they get the diabetic ketosis. And they get the diabetic coma.
Actually, this one is also important, though.
No.
We don't have
You
to
see,
know.
that's important to understanding, but it doesn't come to the exam. It's different. But this one is very, very important. 100%. And it's written, oxidation of an alcohol by NAD is also happens. Could you please tell me why this sentence is important?
Because with an alcohol...
If the oxidation of an alcohol happens by NAD, it means in alcoholis, most of DNA, most of NAD is used by alcohol. Therefore, they get deficiency. In NAD. And because most of the drug, most of the enzyme, most of the useful enzyme needs NAD, there is no NAD for them. And they get the problem in other organ. Why most of the drug is contraindicated by a simultaneous time with alcohol? Because alcohol use NAD to metabolize. All of the NAD comes to the liver to metabolize the alcohol to ethanol to acetaldehyde to acetic acid. Do you remember ethanol, acetaldehyde, acetic acid? And there is a deficiency of NAD in other organ. Understand it?
Yeah.
Later, not later, you should learn it before that, or I don't know, after that. In the glycolysis, we need NAD. You learn it also in biology. In mitochondria, what's happened? A lot of NADH is produced. NADH is produced from NAD plus.
Yeah.
If I don't have NAD plus, the glycolysis and citric acid cycle are done.
Yeah.
Because of that, all of the alcoholics, they get the energy deficiency also. Understand it? And because of that, most
So
of
no
them.
ATP is produced and...
Yes, no ATP production.
Okay.
because NAD is the most important cofactor. Now, all the chemistry of the pyridine nucleotide coenzyme take place at the 4 position of the pyridine ring. 4 position of the pyridine ring. Okay, this is a pyridine. This is a amide. This is nicotinamide. 1, 2, 3, 4. Okay, it said to the 4 is important and 4 will be open. Oxidation of substrate and reduction of coenzyme.
The substrate
You
will
see?
be what?
This is a NAD. NAD accept the proton. It
So
means the NAD is coenzyme. Accept, gain the proton. NAD is reduced and cause the oxidation of somebody else.
Yeah.
No. What's that? So, anything. What has a 2 hydrogen? This coming here, this one, and this one comes here. Okay? And it will be C double.
So this
of
one
this
is the
H.
substrate, the B.
What?
The B is the substrate.
Yeah, I make it right. The H is here. This proton is here. And it was 1 hydrogen before. This is that one. Because we have already one H here.
And this is, but B is the substrate, yeah? This is correct.
B, no, moment. A basic group of the amino acid. No, actually this is a substrate. This is a substrate. No, but this page is not important. Just this information, maybe that's useful. And this is 20%. Just for understanding. The components of FAD. FAD is abbreviation of flavin, adenine, dinucleotide again. Flavin, adenine,
Dinucleotide, yeah.
Flavin adenine nucleotide.
dinucleotide. What does it mean flavin? Flavin is this. This part is flavin.
Do we have that over there?
This is flavin, see?
Ah, yeah.
Flavin. Now, it's come to the exam 100%. It was 300%. No, this is 200%, okay? Now, what they ask? They ask, what do you see? And fill the box. The role, everything actually they ask. No. I want to get the box. This is one box, adenine. There is also a box here, and they ask you the name of the bond. There is one box here, they ask you the name of the bond. What's this? Ribitol. Again, ribitol. Do you know what it means, ribitol? You should know it,
Alcohol.
ribitol. Sugar alcohol.
Sugar alcohol.
Ribitol is a sugar alcohol. Could you please tell me from which sugar it's coming?
From ribose.
From ribose. And do you remember the ribose has R? It means the all of the OH is in the right side.
hand, yeah.
Right side. See, all of them are right side. Ribose is aldose or ketose.
Ketose.
Ribose, there is no L. It means ribose is aldose. No. And flavin is here. And together is riboflavin. Riboflavin or vitamin B2. One more box here. Now, another box that asks you the name of this heterocycle and name of this heterocycle.
Okay, so we...
No. What is the name of this bond?
Which one? Sorry, I didn't see.
This bond?
This is a phosphodiester bond.
No. This is an anhydride bond.
Ah, okay.
Anhydride bond. This bond is N-glycoside
Yeah, because it's switched.
with nitrogen coming. What is the name of this ring?
That is a...
Pyrimidine. But this is not a simple pyrimidine.
No.
It has double on. It means pyrimidine dione.
Oh, okay.
Pyrimidine with 2 keton. What is the name of that?
Not amidine.
This is not the pyrazine. It's a pyrazine, I
It's a
think.
pyrazine, yeah.
I'm not sure. It's a pyrazine, but I'm not sure. Okay.
No, make it...
Check it again.
Okay.
No. This is And this is a FAD is an oxidizing agent like a NAD. Now, could you please, who wants to explain for me why the FAD is oxidizing agent?
Because FAD can oxidize its substrate.
Okay.
So it's
And
it
reduced by itself.
Yeah.
Now, if it's reduced by itself, it means the FAD
Gains an electron.
gains
a proton. So it will be an FADH.
Produce FADH2.
Ah, yeah, okay. Well, so it will gain 2 protons.
For NADH, we put the other proton outside, but for FAD, we get after that. No. That's a very important enzyme reaction, but not now. Later you have it again. Pyruvate produce lactate. Do you know where? In anaerobic condition on the body.
Yeah, is it like when we have this with the muscle?
Catabolic pathway. In the muscle in anaerobic condition. Do you know what is the reason of this anaerobic condition?
Too much sports? Too heavy sports? Or what do you mean?
What is the role of anaerobic condition? Actually, in the anaerobic condition, this reaction happens. Why? What is the role of this reaction? What is the goal of this reaction? Is the goal is produce lactate? Lactate is not so much useful. Why this reaction happens? That's a very easy answering. In biology and chemistry, it's 100% important. To produce, after, beside the lactate, you see?
NADH.
Okay, and no, NAD plus, not NADH. Produce NAD. Okay, what is the role of NAD?
Energy.
No?
No, it can oxidize.
Because NAD doesn't have energy. NADH has energy. NADH can go to the respiratory chain.
Yeah, but it's the starter for the citric acid circle.
This is a star. No, we cannot go to citric acid cycle. We don't have oxygen.
Yeah, but later
Do you know the Cori cycle?
No.
See, come here. The glucose is here. It's coming to pyruvate.
Yeah.
Pyruvate comes to lactate. Here we use NAD and we produce NADH. NADH here comes here beside this reaction and produce again NADY to make a cycle here. From the glycolysis, how many NADH is produced?
4, isn't it?
2.
2.
The production is 2 NADH. In this case, we use one of them. We use one NAD, and we can support that.
Exponential.
Beside this one, 2 ATP is also produced. Actually, we neglect NAD to produce 2 ATP more because we don't have oxygen. Do we get it?
We don't need oxygen.
Oxygen. No. Again, the question on the exam is, what is the goal of this reaction?
Production of NAD.
Yes.
Plus.
Answer is production.
Just a quick question.
What?
The end of the semester is 27th of June.
I don't know. Where are you, Sabina, now?
Sorry. It is, right?
I don't know.
No, it's in May.
No, May is the exam period.
Yeah. Isn't it
From
the end of the
until
semester?
12 of the May.
But is it in May, June? Then it's done. We have May and June for exams.
Yeah.
1.5 months, isn't it?
6 weeks.
Yeah.
Production of NAD plus to recycle glycolysis and produce
ATP.
2 ATP more. The name of this cycling is Cori cycle. Cori cycle.
Okay.
And Cori cycle helped athletes to produce energy for their muscles.
By the way, Ma, can I shortly ask something? How should we plan our exam period this time? Should be chemistry also the first one? What we do?
Chemistry. biology and biophysics should done on the first week, and the rest of the exam is for anatomy histology.
Okay. So not
If
histo and...
You see, if now you study for the midterm of anatomy histo to get the good point, that's enough. That's more than enough for you, okay? And now you finish the chemistry actually. If you study the chemistry for midterm very well, in this case, you can manage it for the first week. Good? Now, you have biology also, and I told you, you should finish biology until before the Easter holiday. Okay? And on the Easter holiday, you have 1 week off. In this 1 week off, you can study lots of biology, biophysics, everything. Now, every day you go to the lecture of biophysics. You don't go?
I do.
Okay? And you have a practice every week. Prepare yourself weekly for the biophysics. In this case, you can finish it very easily. When you go to the lecture, you come out thinking about that, read it, understand everything. In this case, you can just 1 time more study for the exam period and you can manage it.
Okay. Just read a bit and understand it, and then you just have to read some notes and then it's fine.
If you have more time, okay, write the summarize also. If you don't have, fuck it, forget it. If you don't do such like this, I tell you, you want to spend a lot of time for biology exam, biophysics on the exam period, and then you lose the time for anatomy histo, and you should come back on the summer course. And you should pay lots of money, you should lose your summer, you should lose your happiness.
But I'm scared of chemistry actually, because I think it's quite hard.
No. I tell you all of the importance, you know the MRT, you get the point during the semester, you can done on the first exam, and the first exam is easy.
Yeah. So
just make a plan from now for the first exam. Understand me?
Yeah. Like last semester.
Like last semester.
So we should do like first physics and chemistry.
Yes.
And
Give me
then-
the pinkish. And then anatomy histo on the end. You have 5 weeks then to study anatomy histo. This is also less.
You need less than this?
For example, if you are good now on the midterm test, maybe 2 weeks is enough. And then you can go to Balaton and you go to your mother.
Just this reaction is important, not this one, yeah?
No. What's this now? These 2 hydrogen, H and H, coming here and here. That's not a good color. I don't see anything here.
I do.
You see it?
Yeah.
I don't see anything. No, I see it now by the blue. Good. Pyruvate lactate. How many carbon pyruvate has?
2, 3.
3. How many carboxyl?
Oh, 3.
1. How many carbonyl? Carbonyl means just C-double-O. See, carboxyl, carbonyl, carbon. And then this carbonyl, that's a ketone. It's reduced to secondary alcohol. And this is the lactic acid.
Or lactate.
This is ketone reduced to secondary alcohol. Yes? And this is the lactate. How I draw it always? I draw it like this. COOH, C-double-O-CH3. Reduce it to lactate, and lactate is COOH, COH, CH3. I always draw it like this.
Do we have to know the enzyme?
The name of the enzyme is lactate dehydrogenase. Is very important name for sure. Now, over here. FMN. FMN is flavin mononucleotide. Flavin mononucleotide. Actually, you don't see any nucleotide here. Ribitol. What is the name of this box?
Ribitol.
Ribitol. This one is flavin. Together is riboflavin.
Riboflavin, okay.
Dimethyl isoalloxazine benzpyridine ring. The name of this fucking ring is important here. It was also there. Dimethyl isoalloxazine benzpyridine. You know why pyridine? Because pyridine was on the butterfly on that lecture. Pyrazine. with pyrimidine is piperidine. This is a piperidine. It was found on the butterfly. You know? No.
No, she wasn't there, I guess.
No, she was everywhere.
Everywhere.
Serious. See here.
No, she didn't do that.
See, piperidine.
No, I didn't do this one.
And this is a pyrazine. It was, I am right, pyrimidine on the butterfly.
Yeah, but she wasn't there.
Okay, now do you learn it now? Pyrazine, pyrimidine, butterfly. The name is piperidine. Piperidine. It's there, and the fucking name is also here. Again, this is a pyrazine. Now we check it. You are right.
No, we check it.
And pyrimidinone.
Yeah.
Pyrimidine.
Dione. Pyrimidine dione.
Dione. Now, what is the difference between FAD and FMN and FADH2? All of the story, it happens on the isoalloxazone. Dimethyl isoalloxazine. Isoalloxazine. What's happened here? See this hydrogen and this hydrogen together.
That's what?
S-read, it means substrate, reduced substrate, and oxidized substrate. Just this, the two nitrogen coming. But that's not an important reaction.
Okay.
Unlike NADH, FADH2 doesn't dissociate from the enzyme. What this sentence wants to tell you? For the NADH, if this is such an enzyme, this molecule of NADH is come here and then it's go away. There is no any covalent bond between the NADH and enzyme as a substrate or the molecule, okay? But for the FADH, you see this is a covalent bond between them. This is an important information, 50%. Do you understand it?
Kind of, yeah.
See, this is there is covalent bond between FADH2 and enzyme. But there is no any covalent bond between NADH and the enzyme. It's written here succinate to fumarate.
Yeah.
And I always remember this because the fumarate has F, the cofactor is FAD. The fumarate has F and the cofactor is FAD. Now I ask you, the fumarate has two carboxyl double bond and the trans position. If it was cis, it was malic acid. No, the succinate 2 carboxyl, 2 carbon. The hydrogen, which hydrogen go away? One of these, and the double bond 4. In the exam, they ask you what type of reaction do you see? You should write the elimination reaction. Elimination. Why? Elimination. Because we produce a double bond. If we break the double bond is addition. It was one of the fucking questions on the exam, and this is 100% important. Succinate the hydrogen is. It happens on the citric acid cycle. Citric acid cycle, CAC. NAD or FAD? That's a very important question. NAD is used in the oxidation of carbonyl compound. FAD is used in other type of oxidation. And this is 90% usage. And this is 10% usage.
Okay.
Other type is 10%. And this sentence and the difference is 250% important. Okay? Now, do you wanna here oxidize the carbonyl group? No. I want to oxidize CH2. This is the other. But come back here that we use NAD. Why? Because we wanna produce carbonyl. here we speak about the carbonyl, and always we speak about the carbonyl. We want to reduce carbonyl or we want to produce carbonyl, and because of that always we use NAD. Just two places we use FAD, and this is the most favorite one that coming to the exam. And just
so succinate
succinate dehydrogenase.
Yeah.
And because it want to produce fumarate, it produce FADH.
Okay.
F. The coenzyme used for acetyltransferase reaction, and this is 400% important. Just to distinguish, they give it to you this and said what is the name of that.
And the backbones or what?
Yes. No, they fill the box. One of the box is here. This is a cysteine. How should I remember that? How it's cysteine? Oh, very distant. It's a decarboxylated cysteine. Could you please draw me one cysteine? Carboxyl, carbon, amine, yes, glycine,
Yeah.
alanine,
And cysteine.
cysteine.
Yeah.
No, decarboxylated, it means you should see SHCC amine. SHCC amine.
Oh, okay.
Understand it? From here.
No, I don't.
You see, without this, it's still decarboxylated. It's SHCC amine. SHCC amine. The other name is thioethanol amine. Thio
Ethanol.
on the ethanol with amine. Because it was OH before, now this is SH minus.
Oh, okay.
Just remember the fucking middle is pantothenic or pantothenic acid, pantothenate. Because it's very fucking to know everything. You cannot remember it.
Just till the O.
Yes. No.
Double O to O.
If they ask you what is the name of this bond, you can say this is a amide bond.
bond, yeah.
One of my students last semester, she wrote that it's a peptide bond. And fuck you, this is not between amino acid. This is an amide bond. If this is between two amino acid, yes, that was right. This is a peptide bond. Understand me? No. Again, this is ADP for sure because this is the adenine. And on the exam, they doesn't fill this one and just write. Could you please fill also this one? Which nucleotide should be? It should be ADP and adenine, and therefore this is the ADP.
So this is amide bond, yeah.
Amide bond. Other thing that is very interesting here, the ADP is from this one. By this one, this is carbon number 1, 2, 3. This is a 3-phospho ADP.
So we have to write that, yeah? Or
That's a more complete one.
Can we just leave the phosphate?
Yeah. No. Another thing that always you write coenzyme A, coenzyme SH. Why? Because the reactive part is thiol group. Is what?
The reactive.
The reactive is thiol.
You can't read that.
I want to make it beauty. Good? Thiol is reactive part. Because of that, that's important for us. Now, where do we use the coenzyme? Pyruvate wants to produce acetyl-CoA, and the name of this enzyme is pyruvate dehydrogenase system or pyruvate dehydrogenase complex or PDC. Later you learn on the PDC we have 4 important substrate and 3 enzyme: E1, E2, E3. Okay? With complete everything. This is not a complete one. Pyruvate carboxyl carbonyl CH3, the carboxyl remove and produce CO2. Carboxyl group produce what? CO2. And instead of carboxyl minus, coenzyme come here. The proton has a plus charge.
But where's the H?
You see, the proton has a plus charge.
Yeah.
the S will be minus and it's come here.
Yeah.
Where is the H? H is go to one of this enzyme, and later you learn it's go to the lipoate.
So it must be plus H plus actually.
No. This is nothing. It's here is nothing. Later you learn that the product is the usage of lipoate, and it's also produce FADH2. It use NAD but doesn't produce NADH2. The production is FADH2, and one of these H, for example, comes to here finally. But this reaction is important, but you have one complete one later. Here, it's again that table. It's again that table. Bioorganic compounds are amino acid, lipid, carbohydrate, nucleic acid, miscellaneous. Miscellaneous means alkaloid, vitamin, and drug. And in most cases, biological activity depends on the stereochemistry. Now about the vitamin, nutrient. Macronutrient, micronutrient. Macronutrient is carbohydrate, fat, and protein. And micronutrient is daily allowance is less than 0.1 gram. See, my hands is shaking.
Why?
I don't know. Do you see my hands?
I can't see it. Up there, yeah, the camera.
Don't know why my hands is shaking a lot. All of the video, I cannot stop the shaking.
Oh, that's not good actually. You know that.
I
yeah?
put it in my head to shake less. Minerals, trace element, and vitamin are needed. And that's important information.
Just the micro one, yeah?
No, all of them. What does it mean macro? What does it mean micro?
Okay.
Definition. Organic compound. Vitamin are organic compound. Vitamin cannot be synthesized. Vitamin is essential for normal metabolism reproduction. Vitamins must be included in the diet.
Yeah.
They are exogenous source. Vitamins active form and provitamin. Vitamin deficiency disease, we have chemistry different compound and solubility. The different solubility, water soluble, fat soluble. Why do you laugh? To my hand shaking?
No.
I'm old. I always laugh to my grandmother, and now my hands is shaking a lot. I don't know.
It's probably not because.
How much?
Oh,
20. See, it's shaking.
why?
I don't know. And I feel shaking in my eye also, my left eye.
No.
The ricket. This is what? Ricket. This is which vitamin deficiency?
With vitamin E.
D.
D.
Vitamin D deficiency. Fat soluble vitamin is DECA, carried through your body fat and can be stored in your body. In which part can be stored?
In the
In
kidney.
adipose tissue.
Oh.
In adipose tissue or fat tissue it's stored, yes? Vitamins are fat soluble versus water soluble. Water soluble dissolve in water, causing organic material. Here. Actually, that's very important, but it's very important for all of the course, not for chemistry, and especially for biology and pathophysiology. It's very, very important. Now I want to mark for you which part is important. See here, vitamin A is found in the green vegetable and fruit. And for sure, you know the vitamin A is in carrot. Yeah? Carrot. Vitamin D is found in the fish oils and liver oil. And we can get it by sunlight, by sun. Vitamin E is in the green leafy vegetable, in oil, in wheat germ. You know wheat germ?
Yeah.
Actually, we don't eat the wheat germ because we buy the wheat and we buy the rice without germ. Germ is a covering,
Yeah, I know.
skin up. Vitamin K is synthesized from the bacteria in gut is important. And vitamin K is in the cabbage. I want to tell you one story. In the pathophysiology, the topic of Guy Harmon was vitamin. The professor asked, where can you find vitamin K? Arman thinking and doesn't forget the English name of the cabbage. We know it in Persian. I want to give him cheat from the other side. And I was sucked up the vitamin K with potassium. And I said, banana, mouse, banana. And finally he said, could you please shut up? I know, just you confused me. Because potassium is a lot in banana. Potassium is K, kalium. Yeah? Vitamin K is something else. Vitamin K is a kinohydroxy, and this is just a K, is abbreviation of something else. And vitamin K is in cabbage. Okay? And
Yeah.
see, vitamin K in cabbage and potassium mineral is in the banana. And always they ask it in the exam, and please don't confuse it like me, okay? Maybe they are confusing by you also. This is the element, this is just a vitamin. Coenzyme vitamin. The vitamin B1 or thiamine cause beriberi, polyuritis. Vitamin B2 causes pellagra and dermatitis. Nicotinic acid causes pellagra also, dermatitis. Pantothenic is a the neurological problem. All of the deficiency cause this. B6 cause the neurological disorder, dermatitis. Biotin cause the dermatitis, and it's written avidin. And do you know what is the avidin? There is a for example, see, my hands is like a peptide. It's, and on the head of this peptide is something, and the name of that is avidin. And you have it on biology, on the muscle contraction. You know actin, myosin? On the head of the actin and myosin is avidin. And if we don't have a biotin, the avidin doesn't work very well. You have it also in biophysics. Folic acid causes anemia, vitamin B12 causes pernicious anemia. You can read it. I cannot say they are not important,
Just
because these are just a useful table in your future. Okay?
Yeah, but not for the exam.
No,
Not for this exam. Can you write it? Not for this exam.
Maybe, for example, if they ask what is the effect of the deficiency of vitamin B6, you should write dermatitis. And I tell you, most of them cause dermatitis. You see, you can find the dermatitis in most of them. Like a lipid, for example, if they ask what's the role of the lipid, cell membrane protection. And myelin sheath, for example. Okay, here on the vitamin deficiency, you can say dermatitis, because the most symptom is occur on the skin.
Most symptom.
Most deficiency of vitamin is dermatitis.
Okay.
This is for lazier student, okay? Dermatitis. They cannot, for example, this is not here, it doesn't written here dermatitis, but beriberi. The first symptom of beriberi is shown in the skin. For example, you have vitamin A deficiency because you have a dry skin.
But I only have on my hands, so it's done.
Yes, it's only in hand, that's a symptom. Okay, because you protect the other one, the water doesn't evaporate a lot from your other body skin.
But what is beriberi?
That's a
That's
disease.
a skin disease. Not the skin, the beriberi. That's a very good question. I can explain. When they have a beriberi, very, very dry, and it's caused bleeding a lot. For example, they put the hands here and said, "Oh my God, bleeding," and it's so much severe. They die if they don't cure. They die. And in the ancient, there is not here now. Nowadays, there is no any. In ancient, they think that the god don't like this person and they should die. They put them out of the village. There is one movie about that. If you see it. No, the vitamin A is like this.
Why is it called lipid?
Lipid soluble vitamin. It should be like this. Lipid soluble vitamin, vitamin A. First of all of them are trans. See, trans. Do you remember retinoic acid? Retinoic acid and 11-cis retinoic acid, retinol.
Yeah.
Retinol to retinol, and this is a OH. This is the alcohol group. These are the isoperin unit, isoperin, and this is the alpha ionone. You learn it later, and this is not important. Come here. Beta carotene.
They are all fat soluble, yeah?
All of the fat soluble. This is a beta ionon, alpha ionon. These are on the lab manual. Explanation is in the lab manual, in the MS and in the HPLC. We should mark yellow